Hey guys, welcome to another video in this series on reinforcement learning in MATLAB. So again, now we will go further into using this reinforcement learning toolbox in MATLAB to solve the same environment that we have been working with. So previously we solved the mountain car environment using a Q table, which is sufficient, but then for more complicated environments, you might want to use the deep neural networks for solving those. So hence deep reinforcement learning comes into the picture. Now, when we solved our environment, we had to define all these parameters. And for example, this epsilon decay thing, we had to perform manually. We initialized the table manually. And then this whole training loop we had to write manually, especially the part where learning happens. So there's a lot of things that you have to do manually where things, and so there's a lot of scope for things to go wrong. Q learning, or rather tabular Q learning, is relatively an easy algorithm. So, but when you go to deep reinforcement learning, the algorithms become more complicated and the chances for messing things up become higher. And also, you don't want to implement these basic things from scratch again and again. So it would be easy if some backend took care of all these things like plotting, testing, and the whole training loop. And the reinforcement learning toolbox, that's what it does. So let me open the reinforcement learning toolbox. So again, I'm using MATLAB 21A, which has this new tool called Reinforcement Learning Designer, which is just like the Deep Learning Designer. And let's open that up. So I typed in Reinforcement Learning Designer, or you can also open it up from the apps section. It takes a couple of seconds to load in for the first time, and here it has loaded itself up. So what are the first things that we want? We want an environment, we want an agent, right? So these are the you need an environment, you need an agent for reinforcement. So if you click new, MATLAB gives you a certain list of environments that are already pre-programmed into it. So these come shipped with MATLAB, but we don't want to use any of these environments. We want to create our custom environment, or rather, I want to use the same environment from OpenAI-GYM that I have been using. So for that, we need to create a custom environment. And I will walk you through how to do that. So that is one thing. And again, so let's say I chose an environment. Then you have to make the choice of choosing an agent. Now, agent refers to um, the solver that you will be using. So basically, agent is something that solves this environment, and there are different kinds of agents that you can use. So when I click on new, I get this dialog box of agent, and I can choose different algorithm that I want my agent to use. So we will be using deep Q learning, so deep Q network. In the next video, I will talk about how deep Q network works. But then for now, just think of this as a generalization of that Q learning we used last time. And it is exactly that. So, okay, so we use deep Q learning. So, oh, did I not select an agent? Oh, I did. It just takes a bit of time to load in the agent. Right, so this is my DeepQ network agent, and all these are parameters associated to it. Now I can again look into the details of this agent by clicking in. So this agent is called Critic um, because it calculates the value of a given state. That's why it's a Critic network. And when I click on View Critic Model, it's a neural network with so many layers and so on. So this is a default network that MATLAB made for us. So just out of the box, using this app, you can just load in an environment and load in an agent with a given algorithm in a matter of seconds. So now what we want to do is we want to create our own agent and we want to create our own environment. So in this video, I will demonstrate how to interface with the reinforcement learning toolbox to create my own environment and also to create my own agent. That's the point of today's video. In the next video, I will show how to perform training and what deep Q learning is. But then let's close this up and let me show you um, how do we get our model and agent loaded up. So for this, before I get to it, let me just show you the reinforcement learning toolbox documentation. Again, as with all MATLAB documentations, this is spectacularly written. And since we're talking about environments, you can go to this MATLAB environment section, and then it tells you how do you create an environment and some predefined environments that you might want to load in if you want to work with some predefined environments. But we want to create a custom environment that has which is completely custom, right? Because we are using this OpenAI-GYM library. So I want complete control over my environment. So this is a documentation that talks about um, how do you create an environment. So basically, this command generates a template script for you, and then you build up on it to create an environment. So basically, I will be following this documentation, but then obviously it's heavily modified to suit our needs. And finally, to check the validity of the environment, we use this validate environment script to see if the environment is valid. So let's see how we create our environment. And since this involves a bit of code, so I've already typed out the environment in a script, which again has been uploaded to the GitHub page as well. So here it is. Okay, so let me walk you through this code. So the first thing is we create a class called mountain car, and it inherits from rl.m.matlab environment. So for our environment to work with the toolbox, you need to subclass your environment class from this parent one. And then we define the property where basically we load in our environment. Again, this is the Python interface as we talked about previously. So this open and env variable contains our environment. Then first, let's talk about the constructor. In the constructor, certain default variables are defined, and these have to be just the way they are because you're subclassing from this MATLAB environment, and you need things to have a certain name for them to work. So first of all, there are two important things. You need to tell the environment what kind of inputs or the state inputs it sees, the dimension of state inputs and what kind of inputs they are, and also what is the kind of action that your environment takes in. So these are the two important things. So observation info is basically what is the dimensionality of the observation and what kind of observation it is. So here I have specified this RL numeric spec, and this is the size because I take in two values, the position and velocity. That's why the size is 2,1. It's fine. I could also make it 1,2. That doesn't matter. But then I go with 2,1. Now numerical spec basically tells MATLAB that it is a continuous value and it's unbounded. So if I go to documentation and I type in numeric spec, so it shows that it creates continuous observation data specification. So that's what numeric spec is. Now then, these are two helper attributes, the name and the description. And again, for action, I specify this quantity RL finite spec. Now finite spec just tells MATLAB that the actions are finite and they're one of these. So the actions could only be 0, 1, and 2. So that's what MATLAB knows. So if there was another action with say the value 3, I would add a 3 over here. So that's what finite spec is. Again, you can find the list of all these specific methods in the documentation, but then this is all we need. And then again, another helper method, acceleration direction, just tells you, it's a description. And then finally, I return out this object with all the other methods of this superclass implemented. Basically, this implements all the reinforcement learning methods with the following parameters. Now, that's pretty much it for the constructor. So the bare minimum class requires a constructor and a step function and a reset function. So these are the two things that we need to implement. Now, the step function is implemented in the same way as we have talked about before. So step function takes in an action, and in the environment, we step in that direction. Now there's an int16 because our environment only takes in integer values. So this is it returns a Python tuple which needs to be converted into a cell, and then from that we extract out the observation reward and whether the episode is done or not. And then here I manually put in this condition that if my cart has reached a certain point, consider consider the episode to be over. That is just a helper function that I put in. That's about it. And so I just put this in to promote training. The correct value for this should be 0.5 because that's the goal state. So I should probably put 0.499, something like that. But then this works as well. Now, finally, the reset function is when you want to reset uh, the the state, and this is what that's doing. So this is a wrapper class for for the OpenAI environment, and this wrapper integrates the OpenAI environment with the reinforcement learning toolbox. So let's see if this works. So now I define a variable, say a, for lack of a better name, and then I um, create an object, and then let's validate that environment. Great. I didn't get any error. That means it worked out fine. Now that is done. That's great. Now we need to, so environment done. Now let's talk about the deep learning network. Yeah, so I have a script over here. So let me bring that up. This is the deep learning network I have, and I'll just run the script and then talk about what it does. Basically, in deep Q learning, so in tabular key learning, you had a table with the Q table, which had states and actions. So for a given state and action, you would have the Q value associated to it, right? That's how Q value, the tabular Q learning worked. Now, in deep learning, or rather deep Q learning or deep reinforcement learning, instead of having a table, we will have a network, and the network would take in the state, and it would have the actions as output. So here we could have three possible actions. So in deep Q learning, your network would have three possible outputs, and the values for each output would be the corresponding Q value. So you take in the state, and then you have three possible outputs, and the first output is the Q value for action 0. Second value is the Q value for action 1, and the third one is the Q value for action 2. So the outputs correspond to the Q value of the respective action. So that's a slightly different way of looking at Q value. So you only take in the state as input, and you output the Q value for all the actions, if that makes sense. So here I have created a network, and let's look at this network in the deep network designer. So I load in this network, and then let me open the deep network designer. All right, so that'll take a couple of seconds to load in, and let's see. For some reason, things open in a different window for me. Right. Oh, where did it go? Okay, so I load in this variable um, from my workspace. So here's my, okay, let me get it over here. All right, so this is the small neural network my code created. Um, oh, let's see if I can also put them side by side. You don't need to create a network using code, but then it's just easier. Or you can just use a deep network designer as well. And I'll have a video about deep network designer. So either is fine. So basically, I have an input layer which takes in the input of size 2 because, again, our state size is 2, its position and velocity. And then I have a fully connected layer with 24 neurons, ReLU layer, and a fully connected layer with 48 neurons, and another ReLU layer, and then output. Notice again, my output is 3 because we have 3 actions, and I get the Q value for all these 3 actions. And then finally, I need to put a regression layer output, which calculates the mean squared error. So that's an additional thing that you need to put for this Q-learning network. This automatically implements the mean squared error loss. Now, one important thing is that the input should always be, the name for the input should always be this, input underscore 1, and the name for the output should always be representation loss. That's the way the deep Q learning algorithm works, and that's what it should be. You can change it, but then that requires some manual implementations that I don't want to get into. So for now, just take this as a fact. All right, so that's our network, and that's our custom network that we created. So let's see if we can load all these things into our reinforcement network learning designer. Wow, that's a mouthful. Okay, so let's open up the reinforcement learning thing. Great. So we to import our own network or environment, we click on import, and then it automatically identified that there is an environment in our workspace called A, and I click on it. Boom, our environment is loaded in. Great. And you can also see the properties of the environment that we set, the action size and, excuse me, the action size and the observation size. Great. So that's the environment. Now, if I want to load in my network for Q-learning, so first I need to specify the algorithm that I'm using. So first I select in DQN, Deep Q-learning. I take that in. So I get an agent, the DQN agent, and then I import what kind of network do I want to use. So I don't want to use the default one, so I click on layers, which is the one that I created, and that has been loaded in. So just to check if that's the one that's been loaded in, I click on this and I click on view critic model. And here you see this is the same network that we created, 24, 24, 48, 48, and 3. So great. So now we have been able to load in our own environment. And that environment was created as a wrapper class between reinforcement learning and OpenAI. So OpenAI-GYM. So we were able to load in a custom environment. We were able to create and load in a custom environment, and also we loaded in a custom network for our deep Q learning. So I think this is where I would like to end this video. But before I end, I want to mention a couple of things. So if I go back to the documentation for reinforcement learning toolbox in MATLAB, and I go to this agents bit, you would see all the possible agent types that there are there. And you can play around with different types. And also you can, if you want, you can create, you can see there's a reference for creating your own custom agent. So pretty detailed toolbox, and contains a lot of implementations, and so definitely it's pretty useful. And yeah, so at this point, we've loaded in our environment and our agent. In the next video, I'll talk about what deep Q learning is, and also finally performing this whole experiment, training our agent using that app. So that's about it. You can again find these codes on my GitHub page. Link for this is located below. And also check out my other tutorials on reinforcement learning and even deep learning in MATLAB as well. So see you next time.